Hi, we are the Suspension Subteam within UCI Solar Car. Our presentation today will showcase our hard work that we have accomplished this spring quarter of 2021. And I'm Jason, a third-year mechanical engineer.
Hi, I'm James. I'm a second-year mechanical engineer.
Hi, I'm Roma, and I'm a first-year mechanical engineer.
So a quick overview of what we have accomplished throughout the year. So during fall quarter, most of our effort due to pandemic was mostly work at home. So what we ended up doing is a lot of redesign and optimization. We drew a lot of free body diagrams, did some calculations and simulations, mostly static and buckling. And our main goal was to reduce weight. Our winter quarter was more preparation work. It was preparation work for spring quarter for manufacturing. So during the winter quarter, we did a lot of testing and prototyping. So a lot of tooling design and 3D printing, and a lot of documentation and fabrication drawings for manufacturing preparations. And this quarter, we've essentially focused mainly on just manufacturing. So a lot of our parts were essentially modeled, drawings were made, and we just had to get them machined. We tweaked some tooling designs that we had made because now that we're in person, we got real-time feedback on our measured parts. We did some repair work. We did some profiling for additional members to install onto the chassis for suspensions, and did some visual inspection to locate the location of the control arm mounts. So we'll start with design and manufacturing.
So one of the main components that we had to manufacture were the control arm mounts for both the front and rear suspensions. So these fabrication drawings that you see right now are for the lower and upper control arm mounts for the front suspension, which show that the mount is made out of 3 pieces to be welded together, 2 tabs and a base. Next slide, please. So a closer look at the models for the mounts shows that we had to design the mounts to be different lengths, and this is because we had to account for the chassis member that the suspensions would be attached to that was slanting inwards. So the lower control arms also had a slot to allow us to change the placement of the control arm before welding on a washer to finalize the position of the lower control arm. And here you can actually see the placement of the control arm mounts onto the chassis and how they'll connect to the chassis and the control arms. And the control arm mounts will be welded onto the chassis, and we're currently manufacturing that. So as someone who's been working remotely, most of my work was creating the fabrication drawings for this. And so similarly, we needed to do the same thing for the rear suspensions. So there were 2 different designs for the driven and the non-driven side, whose manufacturing drawings you can see here. Our team member James led the initiative for welding the parts together, while team lead Jason and aero team lead Ayush carried out the laser cutting for the individual parts. Next slide, please.
So in the picture presented, kind of simulates what the actual connection to the chassis looks like for the rear control arm mounts. Next slide. In the next slide, basically after the parts were laser cut, I then followed to weld the parts together via TIG and MIG welding, and ultimately was able to manufacture all of them.
As for the rocker, most of this drawing was made for mostly documentation purposes. So we wanted to make sure that the dimensions were in a way easily seen through a chart. So since most of our parts are laser cut, we aren't really sending these documents to a machine shop or a technician who's going to manufacture these. So we also did a lot of DXF files to be sent to the laser cutter. And here's an example of our rocker. So most of our material is made out of steel, and our main manufacturing technique is laser cutting. Here's another one where we have the rocker mount. Same concept. We had our critical dimensions listed, but this one happened to be quite well documented for fabrication in case laser cutting wasn't an option. And here we illustrate where it's going to be used. It's going to be holding the rocker, which is going to be attached to the shock and to a push rod.
So below the rocker is the rear suspension shock mount. Currently, you can see on the screen kind of like the engineering drawing that was created for it. The next slide shows kind of the before and after pictures and kind of the placement of the shock mount on the chassis. Initially, we came with the issue of having aluminum for kind of the base of the shock mount. So we had to kind of create another sets of bases for the shock mount, and then I proceeded to weld them with MIG welding.
So this is our push rod. As you can see, we have 2 different configurations, and that's because we have 2 different suspensions in our vehicle. Our rear right is a driven, we call it driven suspension because that's the one that has a drive shaft connected to. And the other one, the rear left, is similar to the front 2, which are just freewheeling wheels. So they're just following. This is an example. What we end up doing is we tap both ends, left-handed and right-handed threads, and then we place left-handed and right-handed threads, eye bolts onto the push rod. Now we're going to talk about tooling and prototyping. Sorry.
So for the wheel hub, an issue that we found was after basically inserting bolt, there would be an excessive amount of pressure on the bevel of the wheel, and thus there's potential that it would bend and kind of alter the shape of it. So to counteract this, I created a 3D model in SolidWorks to kind of have an adapter solve this issue. On the left, you can see kind of my first iteration of the model. In the second iteration, I proceeded to make the model flush with the wheel hub and also inserted the correct hole for the bolt.
So James just mentioned the need for a wheel hub adapter because we had a different wheel hub. And so one important tool for us for the creation of our suspension was this wheel hub alignment tool, whose fabrication drawing you can see. And so the wheel hub and the rim that we had different bolt patterns. So we needed to drill holes for bolts into the rim, which was achieved with the help of this tool. And the tool was 3D printed using PLA. Next slide, please. So these are a few pictures of the wheel hub alignment tool on the rim. As you can see, it fits into the hole for the wheel hub and gives a clear understanding on where Jason and James needed to drill the rim. Next slide.
Yeah. So before we go to the next, I want to provide a quick overview. So the rim that we purchased is not compatible with the wheel hub that we have. So this is a 4-bolt pattern, but the diameter doesn't match our wheel hub. So that's why we needed this tool. It essentially helps us locate the center and drill the proper bolt pattern onto the rim. So once we place it at the right positions, we used a mill and we drilled it through. So this is our final result. So we drilled holes and now we have the proper bolt pattern to put our wheel hub onto.
Okay, so before the front suspension could be integrated onto the chassis, we needed to actually add a chassis number to the chassis so that we could add the suspension onto the chassis and weld the controller mounts to the chassis. And the location of this member was crucial to ensure that our suspension worked as intended. So we created this simple chassis placement tool that could be stuck onto the chassis and serve as a guide for the location of the new chassis member. Next slide, please. So as you can see in the image on the right, one of our members is holding the tube in place on where it should be on the chassis, but we needed an actual tool to make sure that it was in the actual correct place. So we created the tool and we laser cut it out of wood. And it was used also to keep the tube in place when welding the member onto the chassis. And so here you can see the tool in use. Next slide, please. Okay, so another important tool that we needed was one that measured the correct length of the shock mount. When we created the initial part for the shock mount in our assembly, you can see that there was still an initial gap. There was still a gap after creating the initial part. So we needed to validate that the length was correct, and if the length was incorrect, then we needed to fix that. So James and Jason spearheaded this effort. Next slide, please.
Yeah, so as Roma had stated before, this specific piece, it wasn't a good idea to manufacture it right away as we had no idea whether the lengths were accurate at all. So what we needed to do is we needed to create a tool. So in this case, we made a prototype tool where we decided to have enough adjustability in terms of length and angle. So over here, since we have slots, we can basically use this to slot back and forth to essentially determine what the proper length is. And then since this is also rotates about this center, or this axis over here, it would also help us determine what the angle was. So this is our process where we basically printed it out and we installed hardware. Now, what you see over here is a different prototype. So once we figured out what the correct length is, we basically made a new prototype of the correct length. Now, from this picture, you can notice that the lengths are accurate. However, we didn't know where the placement of it would be. So from this exercise, we realized that we needed to do some more cleaning in terms of where this node is, because our shock will output quite a lot of force, and we want to make sure that nothing really breaks or buckles. So this node over here is quite critical for our application. So now we're going to focus on assembling.
So this is the front suspension at a glance, and we're using a double wishbone system. And because we have a rear wheel drive, like Jason stated earlier, the front suspension is the same on both sides of the car. And the control arms, the wheel hub, or the tire, and the damping system are all off the shelf.
So now to the rear, it's a little bit different, mainly because now we have to have enough clearance for the drive shaft to go through. So if we look at the left suspension, there's no knuckle over here because we aren't really focused on powering this specific wheel. So in a way, this is just freewheeling, and due to that, the suspension has to be different because there's a push rod going right through the middle, and we can't really have that in our driven because, as I said before, a drive shaft will be located there. So now we're going to focus on our driven suspension, which is our rear right. So as I said before, we needed enough clearance here in the middle to make sure that a drive shaft could fit. So this is an example of it. Since we didn't get the chance to weld these on, most of our efforts were put into visual inspection. And this is what you can see over here. So we temporarily placed our suspension parts onto the chassis to visualize whether the placement is okay and if there was any clearance issues. So one thing that we realized from this exercise is that there is too much clearance for our hardware. So what would end up happening is things would slide around unintentionally. So what we ended up doing is we added custom spacers that we 3D printed it out. So if you notice this black piece over here and this black piece, these are custom made spacers that we 3D printed it out. And this is basically a better example. We just 3D printed these out so to prevent things from sliding around, basically. Now, this is the non-driven suspension, and this is the suspension system that we focused on a lot this quarter. So as you can see, we've basically welded everything together and we placed essentially most of the parts together as well. So now to manufacturing.
So since I joined in the second week of this quarter, I realized that kind of my efforts would be best allocated in manufacturing. So I took the initiative and took a class in MIG welding and proceeded to kind of create these and manufacture a lot of these different parts for the chassis. One thing that came up during this process, however, was kind of a very necessary change in addition was the chassis node repair. Kind of the issue with the node in the first place was that it needed to be profiled effectively to kind of attach certain parts to it, and the overall like radius and curvature was too thick to be kind of added onto the chassis. So I proceeded to grind down kind of each node, and the issue that came up was that, as you can see in the left picture, there's holes within the chassis node. To address this issue, I basically MIG welded kind of attachment parts, like additional parts to the chassis, and strengthen the overall node.
Yeah, and that is most of our accomplishments that we have achieved this quarter. Thank you for listening, and goodbye.